Alrighty, transformations. The objective of this video is that one, we're going to want to identify what the type of transformations are. And then two, we want to be able to take a picture and try to identify what the type of transformation is from that picture. There's a lot of vocab on this. I'm not going to read all of these definitions. If you need to, pause the video to look at the actual formal definition, but I'm going to kind of give you just a summary of what they are. So what is a transformation? Well, transformation is basically when you take a geometric figure or a shape or something, and you're going to change the size, the position, or the shape of that object. So I'm going to use this stapler for a reference. So what you're going to have is you're going to have an original thing. Pretend this stapler here. That original is what's called a pre-image. So basically the original figure before you do a transformation. Well, what happens after you do the transformation? That's what we call an image. So the resulting image or the resulting shape after you do that transformation. So that's what an image is. Now, there's kind of two broad umbrellas for transformations. The first one is what's called a congruent transformation. We sometimes call that isometry. Basically, what that means is that you're going to take this image, this shape, this geometric figure, whatever it is, and you're going to keep it the same size, the same shape, but you're going to move it. So I'm going to move it, I'm going to spin it, I'm going to flip it, I'm going to do something with it, but it's going to still stay a stapler. That's what you're going to end up seeing there. So pre-image and the image, they have to stay congruent. That's why we call it a congruent transformation. Well, the other one is a non-congruent transformation. That's basically when you do something to make the pre-image and the image different sizes and shapes, so not congruent to each other. That's what we have there. So let's get a look at some of the different types that we have. So one congruent transformation that you're going to see is what's called a translation. Basically, what you've got is you've got your pre-image and you're going to move that image along a vector. We'll tell you the definition of a vector here in just a second, but it's basically I'm taking every point on this and maybe I'm moving it 5 inches down and to the right. That's what you're going to see. So that's what a translation is. Now, a vector is basically just going to be something that's going to tell you not only a distance, but it's also going to tell you a direction. So maybe if I tell you to go 5 meters up and to the right, that's a distance and a direction. That's a vector. You can travel along that. And again, translation is just moving every point along that distance. A reflection, you're going to have what's called a line of reflection. So pretend my pen is a line of reflection here. All you're going to do is take that pre-image and you're just going to flip it over that line. So if I'm here and I flip it, I'm going to flip it over that line. That's what you're doing when you have a reflection. So again, pre-image and image, they're just a reflection over that line of symmetry. The line of reflection. Rotation, you're going to have kind of a point of rotation, and all you're going to do is just take all of the points of that object and you're going to rotate it a specific amount of degrees. So maybe I take the stapler and I rotate every point of that stapler 90 degrees. Pre-image, image. That's what you're going to see there. All right, and then the last one that we have there is a non-congruent transformation. So we're changing the size and the shape, but we're going to do a dilation. So basically, we're going to make things bigger or smaller with that. Think about your eyes. You can do this at home and do this as kind of an experiment. If you take your flashlight from a phone or something and shine it in your eye, you're going to notice your pupil is going to get really, really small because it's closing your eye to let less light in. Well, if you go into the dark, and stay in there for a little while, you're going to notice that the black part of your eye is going to get bigger because it's trying to let more light in. That's an active way to kind of see dilation. All right, let's take a look at some examples here. So first one that we have here, anytime you're looking for a transformation, really kind of the two things you want to look at. One, is it the same size and same shape? When I look at these arrows, yes, they look like they're the same size and same shape. So I would say that they're going to end up being congruent to each other. The next thing that you're going to want to look at is you're going to want to look at its position. And so when I look at this, it doesn't look like it's flipped. It doesn't look like it just gets slid. It looks like it rotated. And so that just means that we're going to be looking at a rotation for my type of transformation. All right. Next one, when we look at this, again, looks like they're the same size and same shape. It doesn't look like it's rotated, although it's kind of hard to tell. Same thing with flipped. But it does look like I just shifted everything. So kind of along this vector, I just kind of shifted all of those points along that specific vector to get over there. So I would say this is a translation. All right. Next one here is this. This looks like I could just put my line of reflection right down the middle here, and it looks like I can just flip it. So I would say that this is a reflection. And then my last one that I have is just going to be this right here. This one, it does not look like they're the same size or the same shape, so this looks like a dilation.